So this is lecture 27 of Math331 problem solving. And so what I want to do today is I want to go over tic-tac-toe. I think we are all fine with the theory of the original game. Yes? All right, just really fast. So we'll call it classic tic-tac-toe. And again, I believe everybody here knows how to play tic-tac-toe. We've talked about how many different games there are and how to go through and analyze how many different games there are. Where do you want to move if you go first? The middle. I mean, as long as you play well, it's not going to really matter. If you and the other person play well, all games will end in a tie no matter where you start. But if you're playing somebody who's not as good, go for the middle. What's nice is there's only two possible responses. Right? So when you're trying to understand the flow of the game, all you have to do is figure out, well, if the person goes in the center, for the first part, do I want to go in the corner or do I want to go in the middle? One is a good move, one is a bad move. Which is the bad move? The middle. So this is a really bad move. What would you now do if you were X? So you could go over here to this corner, threatening a 3 in a row this way. This would force O to respond over here. And then you could go over here as an X and threaten 3 in a row two different ways. You could go over here as an X and threaten 3 in a row two different ways. So as soon as you go here, then you would go either here or here. Either of those two would work. Okay. Instead of going in the corner, or here, where could you go? So we've shown these two squares work for you if you're X. What else? Yeah, you could go in the middle. If you go over here, this forces O to go over here. And then again, you have the opportunity, if you go here, this is threatening 3 in a row two different ways. If you go here, 3 in a row two different ways. Okay, so far we've got 1, 2, 3, 4 moves that are leading to wins. If you go over here in the middle, wasted move. If you go over here, then that forces O to go up here to block, and then of course you don't have to worry. But actually, let's see what would happen. So if I go here, O has to go here to block. And again, if you play well, you win. So really, if you are playing regular tic-tac-toe, if you go middle and they respond with the side, the only losing move is exactly opposite. In any other case, you can actually force a win. Okay? All right. Let's go back and look at the game we were playing last time. So this is bidding tic-tac-toe. So with bidding tic-tac-toe, we have two players. Player 1, player 2. And the question is, we want to figure out how much money we should be betting. Let's make it so you can bet continuously. We're not going to worry about a tie coin. How much money should we start for each person? 1,000. Doesn't really matter. If we allow ourselves to bid continuously, we could now have 1,000.2397. So we're doing 1,000 because I liked 1,000 from last time, but do we really want to use the number 1,000? Could do 100. What else could we do? One seems to be a nice, natural thing to start with. Or you could start with, X for both of them. One of the things I really like about bidding tic-tac-toe is, let's say you are a little bit better tic-tac-toe player than your opponent. You can give them some additional money. And then the question becomes, how much additional money should you give them? For those of you who like writing computer programs, you could write a computer program to play classic tic-tac-toe. You can write a computer program to play bidding tic-tac-toe. For classic tic-tac-toe, if you put in the strategy, the optimal strategy, it's not that bad to program. What you could do is you could actually make levels of difficulty. So for a lot of games, it's very hard to figure out how do you want to do these things. What's the easiest strategy for somebody to do for tic-tac-toe? To program. Random. Right? If there are 7 squares available, you randomly choose a number 1 through 7 and just go to if you choose the fourth available square. That's a really easy strategy to program. What's the next easiest strategy to program that maybe makes a little bit more sense? Yeah. If your opponent has 2 in a row, block off. What if your opponent has 2 in a row 2 different ways? You just want to make sure that you have it set up so that the computer doesn't freeze, that it actually chooses one of the 2. Or blocks both of them, which could be a fascinating situation where all of a sudden, wow, oh, went twice, blocked me in 1. Amazing! Years ago, I might have told you the story, my brother and his friend were playing a baseball game, and you could create your own characters. And so one of them created the perfect pitcher who always strikes everybody out. The other created the perfect hitter who always hits a home run. The 2 of them faced off, and this was on a very old computer, at least 30 years ago. And the computer hung for several minutes trying to figure out what happens when the perfect hitter faces the perfect pitcher. And after several minutes, it did come up with a reasonable answer. I'm sorry? Nope. Pitcher always strikes out the batter. Batter always hits a home run. Nope, but that's close. What's the average of a strikeout and a home run? A double. So after several minutes of hanging up, the computer finally gave the batter a double. But you want to make sure when you program stuff like this that you do put in little cases, little warnings. What happens if the input is not as I expect? In number theory today, I'm going to be talking about the 3x plus 1 problem, and I'm being a little bit careless and not actually putting in a condition check to make sure my number is even before I divide by 2. It's not a bad idea to put something like that just so you don't have things continually running. Okay? Let's try to figure out some very simple strategy here. What do you think might be the simplest thing we would start off by trying to figure out? For bidding. The simplest possible move we're trying to understand. And we may not get perfect information on this. I care about the thought process. Although this is something that you can play with friends, and if you happen to have an advantage over your friends because you've done some math, that's not so bad. You just pretend, oh, I've never heard of bidding tic-tac-toe. That sounds interesting. Well, you'll be both bidding at the same time, so. Oh, I see what you're saying. So what move would you like to try to understand? Center move? Okay. So one question is, how much is the center worth? The problem is the value of the center is going to be dependent on what the rest of the board is. So the hardest part in chess algorithms is calculating what value do you want to assign to a board. And it's going to be a function of where the pieces are. It's going to be a function of whose turn it is. Depending on how good you are, you might actually throw in some things such as, this person is terrific with bishops. This person is phenomenal with knights. Anybody an Ender's Game fan? Oh, all right, let's skip that reference then. But depending on who you're playing, you might actually say, I really want to get this person's knights because this person is just deadly with knights and I have a track record of their games. So here, I want to understand how much the center is worth. That's a hard question. Now, why did we get our asses killed in the first game against Swarthmore? Or for those of you from Swarthmore, why did you kick William's ass in the first move? We bid too much. Or we think we bid too much. Maybe we actually bid the right amount, but we then bid poorly on the second, and Swarthmore bid poorly on the second, or bid well enough on the second to take advantage of that. So what might you want to try to understand? Your very first thing you're trying to understand about this game. Yeah, how much should we bid on the first move? And if we win the first move, do we need to really decide where we want to go? No. I think it's pretty clear that if we win the first move, we want to go in the center. That's not hard. What was fascinating was we had a game, I think, where the configuration was this. Swarthmore won, and Swarthmore is an O. And then, strangely, the best move for Swarthmore is not to block us, but for Swarthmore to go here because they know that they're going to get the next move as well. And so the actual move of the game can be different than a normal game of tic-tac-toe. So the first question we want to ask is, how much to bid for the first move? So I always like to walk before I run. Can anybody give me any bounds? So if we call that first move, we'll call it B1. What can you tell me about B1? Less equal to X. Thank you. Perfectly useless, but it starts the conversation, right? We can't bid more than we have, and we can't bid a negative number.
We could probably see how much we should, what's the minimum amount that we could bid so that player 2 could win the next 3?
Good. So the first thing to do is to say, well, look, if we bid so much that player 2 can then win the next 3 moves, we know we've bid too much. So let's say we move down to X minus B, and player 2 moves to X plus B. And now we have to really figure out, how do we want to do things? Do we want to maybe normalize things so that we all start off with $1? Do we want bid to be a fraction of the money we have? It's a question of which is the easiest way for you to view the results. Do we want to make X 100? It doesn't matter. They're all the same. But it's which is going to be easier for you to pass. Do you want to set X to be 1, 100, 1,000? Do you want B to be a fraction of X?
Definitely want B to be a fraction.
Okay, so if we're going to have B being a fraction of X, then it might make sense to just set X to be 1. And in the next move, it's going to be a little bit harder, but... So let's set both values initial to be 1 for each, and then move 1. We now move to 1 minus X, and player 2 goes to 1 plus X. Oh, so 1 plus B, sorry, B1. So now we want to figure out, the danger is player 2 gets the next 3 moves. What B1 gives player 2 the next 3 moves? Yes?
I don't know about the exact B1 value, but I know that player 2 has a little over 7 times what player 1 has. In the next 3 turns, it can always bid.
Okay, so let's say we have 1 and 7. Then let's not worry about the epsilon. Let's say player 2 wins every tie. If player 2 wins every tie, since we can bid continuously, all we have to do is give player 2 just a tad above 7, and we can switch things. Right? So just to simplify the analysis on the board, let's say player 2 wins ties. How much will player 2 bid? 1. And so now this will go up to 2, this will down to 6, and player 2 won. Now how much will player 2 bid? 2. So this will go up to 4, 4, player 2 won. And now 4. Right. So I'm sorry. So this goes to 8. This goes to 0. Player 2 won. Now, of course, these were ties. So if we get just a tad more than 7, maybe what we do is we split up our thing up into 5 pieces, and we bid 1 plus epsilon over 5, and then we would bid 2 plus 1.1 epsilon over 5, and then the remaining thing would be on the last one, and then that would be enough to give us. So if player 2 has 7 times player 1, they can get the next 3 moves. What if they have less than 7 times? You can get potentially the next 2 moves, but not the next 3 moves. So this is already enough to tell us that 7 is a critical value.
Yeah, I think that if we want to move past this, we could also say, if your opponent gets the first 2 moves, but you get the next 3 moves,
Right.
You're fine.
Right.
So if you get to a point where,
at least in the very beginning of the game, when there's still 3 squares left in a row or column or diagonal. So when only 2 moves have happened, no matter what, there's got to be a way to put 3 in a row.
Right. So I think what you could say is, how much do I need to win 2 in a row? And then a modified b, like after this, could be.
Okay, so let's say this as a lemma. If have 7 plus epsilon times opponent, we get the next 3 moves. I'm sorry?
You don't have to take those next 3 moves.
You don't have to, but you have that option. Okay, so we'll say if wish, if want. So then what would be the amount needed to get the next 2 moves?
3 plus epsilon.
So would it be 3 plus epsilon? So if we have 1 and 3, we bet 1, so this would go up to 2, down to 2, player 2, 1. We would go up to 4, oh, that's a good piece of chalk too. 4, 0, player 2, 1. So with 3 plus epsilon, we would get the next 2 moves. Okay, so then we would have the following. I'll call this, I guess, 3, and I'll call this 2. If have 3 plus epsilon times opponent, get the next 2 moves if we want. Okay, so now that we know this, let's go back and let's look at what we had a moment ago in terms of how much we should bet on the first turn. So we clearly don't want to bet so much that player 2 gets the next 3 moves. So if 7 times 1 minus b1, the critical value will be when this equals 1 plus b1, we lose. Right? So if we now just go through this, we get 7 minus 7b1 equals 1 plus b1. I apologize for showing all the algebra. I was having some issue coding something for number theory and turned in around 6 a.m. And so I do not trust myself to do algebra right now, as opposed to all the other days when I'm so confident about my ability to manipulate numbers. All right, so we move this over. We get 6, I think, equals 8b1. 3 equals 4b1. So b1 equals 3/4, or 0.75. So we can improve our bound. So we can replace the x, which was 1 now, with a 0.75. So we do not want to bet more than 75%. So now it's beginning to look like, well, maybe $600 out of $1,000. Maybe that wasn't so bad.
I think we could improve it by saying, so we know that with our second one, right?
Okay.
If we have 3 times our opponent, we get the next 2 moves.
Right.
3 plus epsilon.
Right.
So we can say, after 1 plus b, right, I want basically, I'm going to make my move, and I want, if I win my move, to still have 3 times as much as they do. And if I lose my move, I want them to pay me so much that...
Okay, so right now, are we player 1 or player 2?
Okay, let's say we're player 2.
Okay, so we've just lost the first move to player 1.
Right.
Okay, so player 2 has lost the first move to player 1. We're now in this situation.
And what I was thinking was, there's a maximum bid.
Right.
So let's say B2, right, that player 2 would make. And if player 2 makes B2, and they win it, they have 3 times as much as player 1.
Okay, so now what we want to do is here, player 1 won.
Yeah.
And now what we want to do is we want to bid a certain amount so that if we win, we can then do the next 2 moves. So here we want player 2 to win.
Right.
So now we're going to go down to 1 plus b1 minus b2. And here we're going to go to 1 minus b1 plus b2.
And then we can set up like two systems of equations. So we can say 1 plus b1 minus b2
1 plus b1 minus b2, that's the amount of player 2.
equals 3 times player 1.
So it equals 3 times 1 minus b1 plus b2.
And then we can also say 1 plus b1 plus b2, which would be if player 2 just lost the bet.
Okay, so this is if player 2 wins.
We can say player 2 bet b2.
Right.
So if player 2 wins, that would be the case.
If, okay, so player 2 wins, we have this case.
Right. And then if
If
player 2 loses, let's say
player
one
2 loses,
beat them out just over b2.
so now we would have 1 minus b1 minus b2.
That'd be player 1. So like 7 times player 1 equals player 2.
So it'd be 7 times this would then equal 1 plus b1 plus b2.
And then we can solve for both of them.
So we now have 2 equations and 2 unknowns.
And if b1 is lower than 0.75, we have a new upper bound.
Right. So everybody comfortable with this? So in this case, player 2 just won the bet, and now they have to have twice as much. Or here they just lost the bet.
Can we just make these two inequalities just?
Yeah.
Okay, and then we'll graph the region.
Yeah.
Okay, so if player 2 wins, we want this to be this greater than or equal to. And then in this one, if we want 7 times this to be less than or equal to. Okay,
Probably strictly less than, but
right.
doesn't really matter.
And so this is going to give us something in the B1, B2 space. This is where it would be, well, I will erase the tic-tac-toe board for now. We know what a tic-tac-toe board looks like. And I'm just running out of board space. All right, so let's draw the B1, B2 axis. Okay, so we've got B1, B2. So now the first one, we've got 1 plus b1 minus b2 greater than or equal to 3. So let's set this up into a good form. So we've got, the first one is going to become 1 plus b1 minus b2 is greater than or equal to 3 minus 3b1 plus 3b2. So we get 4b2 is going to be less than or equal to, we now move this over here to this side, so it's going to be 4b1, and then it's going to be minus 2. All right, so we get b2 is less than or equal to b1 minus a half. All right, so when b1 equals a half, b2 equals 0, and then it's, so here's 1, here's 1, here's 1/2. It's going to be like this. And we want b2 to be less than or equal to b1, so it should be this region down here. Okay, so this is the line b2 less than or equal to b1 minus a half. Okay, now let's look at the other one. Not turning enough. Okay, so let's look at the other one. So for the other one, we're going to get 7 minus 7b1 minus 7b2 less than or equal to 1 plus b1 plus b2. So we'll get 8b2 on this side greater than or equal to negative 8 b1.
56.
I'm sorry?
56. 7
Oh.
minus 1 is 6. Oh, you did b1.
I'm doing b1 first.
Okay.
I know I'm just so worried about my algebra. I think, oh crap, did I make an algebra mistake already? Okay, so do we get this? Negative 8b1 plus 6 is less than or equal to 8b2.
Yeah.
So we get B2 is greater than or equal to negative B1 plus 0.75. All right, let's see if the camera will toggle. I guess we don't need to toggle that much. All right, so now when B1 is 0.75, so here's 3/4, then B2 is going to be 0. And then when B1 is 0, B2 is going to be 0.75. So it should be like this.
And then we can have a new bound that's the intersection, which looks like it's going to be 5/8.
So we need this point that's on both of them.
Okay. So if we bid 5/8, then there's a corresponding B2, which would be 1/8 that we can bid in the next round.
Right.
If player 1, no matter what player 1 does, if they win or if they lose,
Right.
the next condition is fulfilled.
So if we bid a huge amount on our first turn, then we're in trouble and player 2 has a winning strategy. If we bid too little, it's we should be safe at least for the next few moves. And so what you're saying is, once we bid over a half, there's always going to be a choice for B2.
I don't think necessarily over a half, because maybe over a half.
Oh, wait, we got to shade in the right. We have to shade in the area. The area is B2 is greater than or equal to. Sorry, right? It's B2 is greater than or equal to negative B1. So if B1 is over here, here's the line. We've got to be above this line. So the region that's in both of them is this part over here. We're talking about if the first person bids too much on the opening move, then player 2 will be able to win. So this is the shaded region, which is above this line and below this line. And this is the line negative B1 plus 3/4 is less than or equal to B2. So now, if we bid too much on the first move, if we bid this, then B2 can bid over here and ensure that player 2 wins. So as long as B1 is above this critical value, there will always be a B2 value that works, either by getting the next 3 moves or by losing the first 2 moves and then having enough for the next 3. So we just need to find out where these 2 lines intersect. And so the conjecture was 5/4. I'm sorry? 5/8.
They both have a slope of 1 and a negative 1, so just
Right.
in the middle of 1/2.
Okay. That seems quite reasonable. If we put in 5/8, 5/8 minus 1/8, 5/8 minus 1/2 is 1/8. 5/8 minus becomes 1/8. Perfect. So this will be 5/8. Okay. So we now have a theorem. So theorem. 0 less than or equal to B1 less than or equal to 5/8. Anybody know what 5/8 is? 625.
Or 0.0625. Or no, never mind.
It's it's a hard day to do algebra.
So our move was almost.
So we are pushing the threshold in terms of what to do, right? Does this prove that our move was wrong?
Not yet.
Not yet. I'm still very concerned about bidding as much as 600. We are very close to this upper bound. But in your half an hour of analysis, we have not yet been able to disprove that we made a mistake. Now, do we remember how much we bid on the next round? We lost the next one, so we got some money back.
I think they bid 200 something.
Right, and so, again, we have to maybe bid a little bit more on the second one so that if we win, we make sure we get a sufficient amount of money. I'm sorry, so that if we lose, we get a sufficient amount of money back from them. Since we won, we might not have gotten as much money back as we needed. So this is the analysis just to figure out an upper bound on the first move.
Yeah. I think you could probably figure out if we made a mistake on the second move, though, rather easily.
Okay.
Because you can say, we bid B2,
Right.
and then you can just say if we won B2, or if we lost B2. And if we lost B2, we lost B2, right?
Okay, you're talking about where we were in the game?
Yeah.
Yes, we might be able to actually go back to that game and analyze it. And just see from this point on.
Maybe just with that, right? Like if our B2 was small enough so that it satisfied the first inequality.
Right.
Right there. The 1 plus B1 minus B2 is greater than or equal to 3 times 1 minus B1 plus B2.
Mm-hmm.
Then we would have made a mistake.
Right. Now, in the first game, did we go to 950 after the second move, or was that the second game? That was the second game. So, given that it's already been 35 minutes and we've only done the first two moves here, I will release the paper that you should look at. It was written by two people. One of them, I remember when he was a freshman and I was a graduate student at Princeton. Very nice guy, Sam Payne. I will share that paper as to there is an optimal strategy. And there's an optimal amount how much you should be giving. We actually had a senior give a colloquium talk on this earlier in the year.
How did they do it? Did they just go through every potential possibility and work backwards?
I'm trying to remember exactly how they did it because I deliberately did not want to be looking at this so that I would not be guided in terms of the analysis. I do know the analysis is changed when you have a tie-breaking chip. Now we can somewhat change that with just having this continuous bidding. And with something like this, with the continuous bidding, you can almost get rid of the tie-breaking chip.
Unless you have a hard bound below.
Unless you have but you can always rescale your bids as long as you can bid continuously. I mean, I know a lot of it was an analysis of cases, and there's not that many cases to analyze. And so you can start looking at different configurations on the board. And so it's been a while. What you could do is if you say, let me give you a configuration, and if you have a certain amount of money, how much do you need to force a tie, to force a win, etc. like that. And then what you can do is you start with these states, and then you work backwards. So then if I transition to this state, I need this much money.
This we saw from the beginning where if you win the center, then there's certain kind of configuration that you can always force two wins, in which case the other player has to win two bids to block both your kind of approaches.
Well, I think you need more than just the center.
Yeah.
But so, in some sense, it might almost be easy to start this game from the opposite extreme, from mostly completed boards. But the problem with that is then you have to start off with variable amounts of money.
I don't think.
But it would just propagate.
Every time we add a variable, we add an equation.
Right. Well, here I would replace the ones with say A and B, and then this would probably be. Do I bid a fixed amount B1 or do I have B1 as a fraction? Here we were actually having B2 as a fixed amount. So we do have to be a little bit careful. When we're bidding here, what must be true about B2?
It must be consistent. It must be less than both people's amount of money.
Right. Now, if B2 is larger than 1 minus B1, we've already won. Or have we?
Yeah. I think my guess is if.
Well, because that just gives us the next move. That doesn't necessarily win us the game.
But suitable B2 satisfies both of those next 2 moves if I win, and do I have the next 3 moves if I lose?
Right.
With that. So, maybe a different B2 also would apply.
Correct. We just have to be careful because we need to make sure that this is a legal bid. And it is possible that B2 might be so large.
Right,
But then that would be fine. Then this person bids 1 minus B1 and this person overbids.
right. B2 is what player 2 needs to bid.
Right. Okay. So I'm going to assume we all remember these lemmas, and I can erase these lemmas. So we know it's 7-3. This of course leads to an interesting question. How much money do you think you need to get the next 4 moves?
15.
Yeah, is it 15? Is it going up by powers of 2? Seems quite natural looking at that progression. That's probably powers of 2. Can you imagine a situation where you would need to get the next 4 moves?
If player 1 has.
If you can get the next 3 moves, then either there's a win available, or if it's like
Well, could you need the next 4 moves to maybe stop them from winning?
If you can guarantee that you win the next 4 moves, then you don't need to stop them from winning.
like what? They got the smaller box.
So you just stop 1 there, 1 there, 1 there.
That
So imagine we have this configuration. All right. Now again, in this configuration, player 1 is a moron. Okay. You would have to go as, here, 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 and here. You would have to win the next 4 moves.
But you would also think you have enough money unless you bet 1.
So, again, you could have really bad people playing each other and moving in bad squares. If you've ever watched little kids play tic-tac-toe, they make some interesting moves. So, in a situation like this, here is a configuration where you would need to win 4 in a row. If you assume you have 2 intelligent people playing, this is not going to happen. Well, if you have 2 intelligent people playing, then shouldn't they know the optimal bidding? What's your definition of intelligent? So I'm going to assume a certain basic level of fluency. You know how certain classes have like linear algebra as a prerequisite? I'm assuming classic tic-tac-toe is a prerequisite. And that you are smart enough that you cannot put down x's in this configuration without having had the opportunity to have won. So we will assume that we will never have to get into a configuration like this. So imagine now, so this was the situation in the classic Williams-Swarthmore game. And I think we had 950 and they had 1050. Let's just simplify it again so both sides have $1. All right, I'll go Williams and Swarthmore. And so we both have $1. So now we just need to get 2 in a row. And so if we've already done the analysis to get 2 in a row, that's a factor of 3. Can we do better?
So like the analysis for 2 in a row would just be B1 can't be so large such that Swarthmore then has 3 times us.
Correct.
So 1/2.
Right. So we know that, but we are willing. We don't have to get the next 2 moves. Let's say we get this move over here. Then they have to bid enough to stop us. And so we're happy to get 2 out of 3. And they would be forced to go extremely high.
So if you force them to have to bid.
So basically, let's say we win the next move. So we go down to 1 minus. You want to use B1? We've been using B's before. Do we want to use we're okay using B1 again? Or do we want to use
W1.
all right, W1 for Williams? Ooh, and this goes to 1 plus W1.
And it doesn't really matter.
And now how much does Swarthmore have to bid on the next move? 1 minus W1. And so now we go up to 2 minus 2W1. and they go down to, they have to bid 1 minus W1, so they go down to 2 W1. So if 2 minus 2 W1 is greater than 2 W1, we now get the next move. So here, we'll say Swarthmore wins, and so they go here.
And if it's greater than...
Oh, wait a minute.
No.
Oh, no, this is not enough for us to win, I'm sorry.
But if it was greater than 3 times 2W1,
If it was greater than 3 times 2W1, we would win.
is that...
So 2 minus 2W1, let's say that equals 3 times 2W1. So then we would get 2 minus 2W1 is 6W1, so 8W1 is 2. No, yes. So W1 is 1/4. So if we bet a quarter,
But we bet too small.
right, is we didn't force Swarthmore to go up too high. So let's say we bet a quarter. And so we go down to, we win with a quarter. Let's say we win with a quarter. So we go down to 0.75, and Swarthmore goes up to 1.25. And now Swarthmore has to win the next move. So Swarthmore has to go all in and bet 0.75. So they will go down to 0.50, and we'll go up to 1.25. Now how much did we bid next? So this, I'm a little concerned because this doesn't...
We're at 1.5, not 1.25.
Oh, they bet 7.5. Okay, perfect, good. They bet 7.5, good. So we go up to 1.50, good. So now we bet 0.5 and win. So we go down to 1.00. Swarthmore goes up to 1.00. We go here, and then we both bet $1, and we win. Okay, so in this situation, a good bet for us looks like it would have been maybe
If you win the first one with 0.25, you have enough money left to be guaranteed.
correct, to be guaranteed to win.
So you want to, both teams should bid more than 0.25, because if they don't bid more than 2.5, the other team could win with 0.25, and then the other team would be guaranteed.
So okay, so let's just say this. So let's go back to what the configuration is here. So we're starting off at 1-1. And so you're saying if you win with a small bet, you're in trouble?
No, if you win with a small bet, that's good for you.
Right.
If you let the other team win with
If I let the other team win. So if we let if Swarthmore lets Williams win with a bet of 0.2.
With a bet of 0.25 or less.
Right, so let's say we win with a bet of 0.2. So we'd go down to 0.80, and Swarthmore goes up to 1.2. And now Swarthmore has to bet too much. So you've got to bet at least 0.25 on the next move in this configuration. Anything less than that, and you've exposed yourself to lose. So, you know,
And then you could probably set an upper bound as well.
so you can probably do that as well. So, you know, again, to me, it's the thought process as to how we attack this. I still think we're looking at this the wrong way, or we're looking at it too early in the game. I think we really want to look very far down the path, and then just see, in a configuration like this, what's the thing, and then just propagate it up. My guess is that's how the paper does it. It's been a while since I've looked, but if I had to guess, that's what I would guess. Okay, so I hope you enjoyed, you know, bidding tic-tac-toe. You know, again, I'm going to try to keep the homework content weak and small for the rest of the semester. I will be giving you the third midterm soon, and I will say a little bit more about that in one moment.